Howdy, students. Pete England here, CVEN 424. This is our next talk. We're going to talk about the future in you, the future of you as a civil engineer, the future of civil engineering. This is an important subject, as I think we all know. The ASCE. So I'm going to spend just a minute building my credibility with this discussion. I want to point out that the ASCE is already saying our world is changing at an accelerating pace. Understanding the drivers of change is more critical than ever. Our future will require a new way of doing things, a new plan, a new vision. All right, so that's the ASCE. That's the American Society of Civil Engineers. It's your professional organization saying that the future is pretty important right now, as it always is. They even have a futureworldvision.org website where you can go look at what the ASCE's vision for the future is. So key lessons in this quick little talk are going to be that the future is going to happen. So set goals, right? Be intentional. Make a plan for addressing change or accepting change or recognizing change. Some future changes are not easily predictable. Some future changes are very easily predictable and some are not. So for instance, will computers get faster? Yep. Are cars going to fly? I don't know. I mean, they kind of, some of them, there's a couple of models right now. But if we were to come up with an anti-gravity machine tomorrow, that would be surprising, right? So some future changes are easily predictable, some are not. And your career is going to last a really long time, and it's going to cover a lot of change. So we're going to get through this pretty quickly. Again, talking about the future and change and how we can be ready for it as civil engineers. So, changes that are easily predictable. Population growth. Is the population of the Earth going to change? Absolutely. Is it going to grow larger before it gets smaller? Absolutely. What about climate change? Yep, easily predictable. Increases in traffic. The need to reduce traffic congestion. Absolutely. Those are predictable things that the future holds for us. Things that are not predictable, major scientific and technological advancements. There was an announcement just recently from researchers who believe that they're going to be able to essentially triple the energy density, the energy capacity of your average lithium-ion battery. And of course, there's other batteries on the near horizon right now. I would have expected changes in the battery market, right? But that's a huge change. That means batteries, lithium-ion batteries will have the same energy density as gasoline. And I didn't see that coming this soon. Economic cycles, right? Sometimes the crash in 2008, the market crash, that in hindsight, quite predictable. At the time, a lot of people caught blindsided. Epidemics and pandemics, obviously, COVID-19 caught most Americans, caught most of the world pretty much by surprise. So we're not going to do this right now, but I want you to think about, because we might do this in class, we might do it on a discussion board. I want you to name an unpredictable change that has happened in the last 5 years for you. Anything that someone else would notice, right? So it doesn't have to be COVID-19. It could be something else, like you did not expect how much an electric bike, an e-bike, was going to change your life. I don't know. How has this change affected life for non-engineers, and how has it affected engineering professional practice? Those are critical questions to think about when you think about an individual technological change, right? A change, and you start asking yourself, well, okay, how has this affected non-engineers? How did it affect me? Here's an example. This is an article from 2014, 7 years ago. It shows an exoskeleton, battery-powered exoskeleton, helping a Korean shipyard worker pick up a piece of metal and move it, carry the piece of metal. So when we think about the future, we have a tendency to think about robotics as being the Iron Man suit, right? I'm covered all over, I can do anything. But we don't have to make that kind of breakthrough before robotics plays an important role in our personal lives, right? This kind of system tends to reduce employee fatigue and therefore reduce injuries, therefore reduce mistakes. Therefore, the exosuits tend to pay for themselves. At the time, 7 years ago, U.S. shipyards were only 10% robotic, and Korean shipyards were already 65%. And if you want to know where the biggest and largest and most advanced shipyards are in the United States, it's one of the two countries I just mentioned, and it's not us. Right? 7 years after my exoskeleton article, right? I showed you that guy, and we've got people talking about robot muscles that grow stronger with a workout. 7 years, right? Freshman year of high school, junior year of college. There was a lot of change for you and for me during those years, but that's a huge change, right? 7 years go from robot to what? GUI cyborg type stuff. Texas A&M is thinking hard about the future. Obviously, in the College of Engineering, we're offering new PhD focuses, like you can get a doctorate in future cities, right? Artificial intelligence and data science, that's huge. Automation and civil engineering, obviously huge, right? What if you can just push a button and build the whole site? That would be awesome. Sustainable and resilient natural and built environments, that's going to be huge. I don't think that's as huge as automation right now, but in terms of career and money and opportunity, yeah, all these things are huge. So what's the future going to look like? Those of you who have seen old science fiction movies like 2001: A Space Odyssey, or any of the Star Trek or Star Wars movies, Black Mirror, Ready Player One, is the world going to look like that? Is that what the future looks like? In many cases, yes, and in many cases, no. If you watch filmmakers, watch science fiction movies about the future, one of the things you notice is that sometimes they're not really thinking about the technologies that they're embracing. I don't have an example right to hand. Star Trek, are we going to be just, in the next 50 to 100 years, are we just going to be launching ourselves from star system to star system, from galaxy to galaxy? Seems unlikely at this point, doesn't it? So where do you go for your visions of the future? When you're thinking about what the future looks like, what are you thinking of? Do you watch TV shows like, Black Mirror or Ready Player One or The Walking Dead, right? Is that your future? Or how do you envision the future? Do you read books? Do you read history books and then think about the future? It's an important thing to think about because this is a time of great technological change, and I think it's really going to change how you design buildings. And so, as a civil engineer, where you go for a vision of the future is a critical part of your education. Again, this is Bill Gates, 7 years ago, talking about software substitution, right? He says 7 years ago, he says, I don't think a lot of people are really thinking about it. And of course, today, we've seen some very beginning AI models, the large language models like ChatGPT. They can obviously do a lot of things that we do. Now, are they actually artificial intelligence? Are they going to replace us? No. But right now, they can do a lot of tedious things that we do. And so I think that's something to look out for. I think healthcare, transportation, food service, those are all going to be impacted heavily by roboticization. Okay, so where are we right now, right? So where you're a junior or senior, you're about to graduate. People in industrialized economies have more goods than they need, and they have access to all the information in the world. So think about it, industrialized economy, right? I live in Texas. I have many changes of clothes. I have more than enough food. I have a comfortable, large house. What do I need? And I have access to all the information in the world. If I need civil engineering done, I can look it up, right? So if people have everything they need and they can learn anything they want, why do I need you? Why do we need a civil engineer? This is a critically important question. This isn't a throwaway. What do you contribute to my life that I should pay for? And I think a lot of the answers are obvious, right? AI is never going to know what to do, even if it can do it, right? So a human's going to have to tell the machine what to do. You need to be able to know what the limits are, what can be done, what should be done, right? So a person like me can come up with a civil engineering solution, but is it the best civil engineering solution? Probably not. So we'll talk more about how you can overcome this barrier in just a minute. I just want you thinking, how am I, if machines are doing a lot of things and people already have a lot of stuff, what can I contribute as an engineer? So there's this guy named Daniel Pink. I'm quoting from the Walsh textbook here, but you see down at the bottom, the guy being quoted is Daniel Pink. And he believes that we're coming up on the conceptual age, and that work that can be reduced to a set of rules, routines, and instructions is migrating across the oceans. And in 2005, he was right. We were outsourcing loads of jobs. We're not really doing that anymore. Why is that? Well, because we don't have to. We have software and robots, right? So what Daniel Pink says you can do is do things that computers don't do. Help people visualize what they need and what they want. Help innovate, right? Create new solutions. That's the thing computers can't do yet. Creativity, synthesis, combining existing solutions, existing projects, empathy, expressing, right, the similar feelings and or understanding the feelings that your clients are feeling, right? Because those things tend to lend themselves towards better solutions, right? So it's not just your civil engineering expertise, it's also your ability to relate to other humans. So real quick, human roles throughout history, the reason this time is so much different than other historical times, right? The agricultural revolution took place about 8,000 to 5,000 BC. And so what did we see there? Most people are in heavy physical labor. Huge numbers of people are needed to farm and sustain society. Right? Agricultural revolution. But what happened as a result of the agricultural revolution? Larger cities, much lower infant mortality rates, much longer lifespans, much higher quality of life. Industrial revolution, 1500 to 1800, with some serious exceptions, also contributed to quality of life and your comfort in everyday life. In Industrial Revolution, what are most people doing? Well, they're still working, right? Hard work, but they're working with machines. And what becomes important? The important things are mechanics, reading, writing, right? Industrial Revolution doesn't work without an understanding of how things work. The Information Age, starting about 1950 and ending roughly yesterday. Yesterday is a figure of speech, obviously. Many of us produce information for other people. That's my job. That's your job as an engineer. If you're a lawyer, a doctor, a nurse, a teacher, you produce a marketing agent, you produce information for other people to consume. We are now in the information age. When it comes to predicting the future, Ray Kurzweil is one of the biggest names in the United States. He holds 20 honorary doctorates. I've got stuff here so that you can see that he is a widely regarded and highly regarded expert. But you get to decide whether or not you want to believe him or not. So predictions that he made in 1990 that are confirmed, that he was right. Right? He made these predictions in 1990 and he was right about all this stuff. So I want to jump into the near future, right? Because this is the almost now. By the 2030s, virtual reality will begin to feel 100% real, and we'll be able to upload our mind/consciousness by the end of the decade. That's Kurzweil's prediction. What do you think about it? Do you think it's coming? I don't know. 100% real. That seems pretty cool. All right. By the 2040s, another prediction, non-biological intelligence, so artificial intelligence, right, will be 1 billion times more capable than biological intelligence. Now, is it that way now, or is ChatGPT 1 billion times? No. ChatGPT is not aware of itself. It's not sentient. It's not artificial intelligence in the classical sense of the term. It is instead an excellent prediction model. It's very good at predicting what you want to see. right? So it's not yet more capable, but if you give it, 20 more years, pardon me, maybe non-biological intelligence, artificial intelligence will in fact be a billion times more capable than we are. Nanotech foglets will be able to make food out of thin air and create any object in the physical world at a whim. One of these days, I'm going to leave that one out. It's so weird. It typically blows people's minds. What Kurzweil is talking about is obviously nanobots that are so tiny they can float in the air and they can assemble molecules out of the other molecules in the air, and so they can just create for you anything that you need anytime that you need it. Okay, let's go ahead and skip that one. That's getting uploaded to the cloud. Okay, so how are you going to compete in an age when computers are increasingly capable of doing your job, or at least appearing to do your job? Well, one of the things you're going to do is do things that people can't. Do things that computers can't. Visualize, innovate, create, synthesize, empathize, right? Those are things that computers aren't going to be able to do for a while. What happens when your job becomes routine? Software substitution. So how do you combat that? Well, when your job becomes routine, if you find yourself designing the same thing over and over again for 6 months to a year, you need to change your job. You need to talk to your boss. You need to find a new position, because that job, anything that can be reduced down to a set of rules, right, a process, can be done by machine. And so you're going to be looking to push beyond that, right? And you go ahead and encourage the boss. Yes, this thing I've been doing, that can be done by software. I want to do something that can't be. In other words, be aware that anything you do that's repetitive can be done by a machine. What happens to the design and construction of civil projects? Well, there's an excellent chance you won't be having to design for human construction anymore, because it'll all be robotic or automated construction. Okay, let's try to wrap this up. My goal is to sort of get you thinking about the future, not necessarily to tell you what's going to happen, because of course nobody really knows. But for civil engineers in particular, this is a very turbulent time. It's a good time. I think there's loads of jobs and opportunities and lots of money for civil engineers who are competent. At the same time, there's going to be a lot of change over the next 40 years, and y'all are going to see that. You're going to be right in the middle of it. So remember, the future is going to happen. Set goals. Set doable, manageable, achievable goals. Some future changes are easily predictable. Some changes are not. I'll tell you this one, there's going to be another pandemic. I have no idea when. But a good guess would be sooner rather than later, given increased global travel and increased global temperatures. Your career is going to last a long time, and so you're going to need to keep up. And that's going to mean, of course, reading the news, maybe reading science fiction or watching science fiction movies and thinking about it, talking about it with other engineers, and also the innovation, creativity, all those things that Daniel Pink said we should do for the age of visualization. Okay, that's it for now. This is Dr. Pete signing out. I'll talk to y'all soon.